Welcome, everyone. Today we are focusing on a critical aspect of Azure storage security, managing access keys. As Azure administrators, knowing how to handle these keys securely is fundamental to protecting your organization's data. Let's get started. Let's start with the definition. What exactly are storage account access keys? Whenever you create a new storage account, Azure automatically generates two 512-bit access keys. These are simply referred to as Key 1 and Key 2, or the primary and secondary keys. But why do we have them? These keys serve as the ultimate passwords for your storage account. They are used to authenticate applications via shared key authorization, or they are used to cryptographically sign shared access signature, or SAS, tokens. When you are initially setting up your backend architecture, these keys provide the necessary access to read and write data across all services within that specific storage account. Looking at this flowchart, you can see the foundational architecture. From your central Azure storage account, the system automatically branches out to generate two identical but distinct access keys, Key 1 and Key 2. Both of these keys have the exact same capabilities. As you follow the flow downward, you see that either key can be used directly for shared key authorization by your applications, or they can be used to sign SAS tokens, which delegate access to other users. Now we must discuss the power and the inherent risks of using these keys. What do these keys actually grant? Simply put, an access key gives whoever holds it full, unrestricted control over all the data inside the storage account. For the basics, this means they can create, read, update, or delete any blob, file share, queue, or table. Why is this risky? Because utilizing an access key completely bypasses any role-based access control, or RBC, restrictions you might have carefully set up in Microsoft Entra ID. For our deep dive, it is critical to understand that because they grant this level of access, you should never hard-code these keys directly into your application source code. If that code is exposed, your entire storage account is compromised. This diagram illustrates the sheer scope of access granted by a storage key. The access key node on the left has a direct, unfiltered path to the storage account, explicitly showing that it bypasses RBC security layers. Once inside the storage account, the key holder has unrestricted, omnidirectional access to blobs, file shares, queues, and tables. It acts as a master skeleton key for your data. So, how do we find and use these keys when necessary? The process is straightforward but secured by design. In the Azure portal, you navigate to your storage account, scroll down to the Security plus Networking section, and select Access Keys. For the basics, you'll notice that the keys and connection strings are masked by default. You have to explicitly click a Show button to reveal them. To avoid shoulder-surfing security breaches, it's best practice to just click the clipboard icon to copy the key directly to your clipboard. Diving deeper into permissions, not just any user can see the screen. An administrator must be explicitly granted the list keys action permission in Azure RBC, typically included in the owner or storage account contributor roles to view or regenerate these access keys. Let's walk through the sequence of accessing these keys. The administrator initiates the request in the Azure portal by navigating to the security settings. Crucially, the portal immediately verifies with the storage account whether this specific admin holds the list keys RBC permission. Once validated, the portal loads the access keys blade, but keeps the keys masked. Only when the admin explicitly clicks Show or Copy does the portal return the actual clear text key for use. Because these keys are so powerful, we must discuss key rotation. What is it? Key rotation is the security practice of generating a brand new access key to replace and deprecate an old one. Why do we do this? Over time, keys can be accidentally leaked in configuration files or code repositories. Rotating them regularly mitigates the risk of long-term credential leakage and ensures you meet strict enterprise compliance policies. When should you do it? Best practices highly recommend rotating your access keys at least every 90 days. How is it done? You simply click the Rotate Key button next to Key 1 or Key 2 in the portal. Now, for a deep dive, you might have wondered why Azure gives you two keys instead of one. The entire reason Azure provides two distinct keys is to allow you to perform this key rotation process without causing any downtime for your applications. This flowchart outlines the lifecycle and triggers for key rotation. We start by identifying the need for rotation. We ask, is the key currently compromised? If yes, we route to immediate rotation. If no, we follow the standard 90-day compliance cycle. Both paths lead to clicking the Rotate Key button in the portal. Azure immediately generates a new cryptographic key, and crucially, as the red node shows, the old key is permanently invalidated the very second the new one is generated. Let's walk step by step through the zero downtime key rotation strategy. If you just regenerate a key that an app is actively using, your app will instantly crash. To avoid this, we use a structured 4-step process leveraging both keys. Step 1. You update your running application's configuration to use the secondary key key 2. The app is now running safely on key 2. Step 2. You go into the Azure portal and regenerate the primary key key 1. The app doesn't break because it's not using key 1 right now. Step 3. You update your application configuration again, this time pointing it to the brand new, highly secure key 1. Step 4. Finally, you go back to the portal and regenerate key 2 to secure it, completing the cycle. Why do we do this? It ensures that the application is always holding at least one valid key during the entire security rotation. This sequence diagram is your blueprint for zero downtime rotation. Follow the flow. The application starts by communicating with key 1. In step 1, the admin redirects the app to use key 2. Now that key 1 is idle, step 2 occurs. The admin regenerates key 1. In step 3, the admin points the app back to the newly minted key 1. Finally, in step 4, key 2 is regenerated in the background. The app safely continues its operations without dropping a single connection. For our deep dive, we need to understand the critical relationship between access keys and shared access signatures, or SAS tokens. What is a SAS token? It's a URI that grants granular, time-bound access to storage resources without handing over the master keys. For the basics, you must know that when you generate account-level or service-level SAS tokens, Azure cryptographically signs them using either access key 1 or key 2. Here is the deep dive trap that catches many administrators. If you regenerate an access key, Azure immediately and permanently invalidates any and all SAS tokens that were signed by that specific key. Why is this so important? Because if you have distributed SAS tokens to external partners or remote systems, rotating your primary key will break their access instantly. You must meticulously track which key signs your SAS tokens to manage rotations safely. Look at the ripple effect in this diagram. At the top, access key 1 is actively providing the cryptographic signature for SAS token A and SAS token B out in the wild. Suddenly, an administrator executes a key regeneration on key 1. The dotted lines immediately show the consequence. SAS token A and SAS token B instantly break and turn red. Any client relying on those tokens will now receive access denied errors. This visualizes why key rotation must be planned carefully. If managing and rotating keys sounds complicated, there is an enterprise solution, Azure Key Vault. What is Key Vault? It is a highly secure cloud service designed to safeguard cryptographic keys and secrets. Why should we use it for storage? Because it completely removes the need for developers or administrators to ever see, handle, or hard-code storage keys directly. How does it work? You place the storage account access keys inside the Key Vault. Your applications then authenticate to the Key Vault and retrieve the keys dynamically at runtime. For a deep dive into automation, Key Vault can actually be configured to connect directly to your storage account and automatically rotate your access keys on a strict schedule. This completely removes the manual administrative overhead and eliminates the risk of human error during the rotation cycle. This flowchart maps the modern, secure approach to key management. On the left, the application never holds a hard-coded key. Instead, it authenticates itself securely to the Azure Key Vault. The Key Vault acts as the secure middleman, storing and automatically rotating the storage access keys. The application retrieves the key strictly in memory at runtime and uses it to connect to Azure storage on the right. If the key rotates, the application simply asks Key Vault for the new one. Let's wrap up with the ultimate best practices and alternatives. The most basic rule of Azure storage security is this: avoid sharing or using storage account access keys whenever possible. Treat them as break-glass root accounts for emergencies. What are the alternatives? Alternative 1 is Microsoft Entra ID. You should use Azure RBAC to assign identity-based roles, like storage blob data contributor, directly to users and managed identities. Alternative 2 is using user delegation SAS tokens. Unlike standard SAS tokens, these are backed by Entra ID credentials, not the master access keys. For our final deep dive, if you want to ensure maximum security, Azure allows you to completely disable shared key authorization at the storage account level. By flipping this switch, access keys are rendered useless for data access, forcing every single application and user to authenticate securely through Microsoft Entra ID. This decision tree guides your authentication strategy. When someone needs data access, evaluate the requester. If it's an internal app or user, route them to Microsoft Entra ID RBC. This is the most secure path. If it's an external partner needing temporary access, route them to a user delegation SAS token. Only if you are dealing with a legacy application that simply cannot support modern Entra authentication should you fall back to using access keys, and even then, make sure they are wrapped securely inside an Azure Key Vault.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.